Well, as you can see, this is my Stuart Turner steam engine plant, and you've seen this in several of my videos. In fact, just quite recently I was using it, my lovely Stuart Turner 10H here, to drive the little U-Gears mini helicopter. Well, the 10H now has a companion steam engine. This is a Stuart Turner 10V. Basically, this is simply the upright version of this engine. So, you know, a lot of the parts are very similar, and it operates and functions in the same way. But there's a bit of a tale behind this engine, and it's a bit of a cautionary tale. So we'll close in and have a look at that. So there you go. It's difficult to get a good angle on this because obviously it's bolted down to the baseboard, but so you can see it better from this side. And it looks to be a rather nice little engine, doesn't it? Well, it isn't. It's a basket case. So basically the story behind this engine was I got this from eBay about 5 years ago, and I got it very cheaply. That should have been a good indication, shouldn't it? And the seller said it had some issues and it didn't run, but it was all there. So I thought, well, okay, well, yeah, you know, it was all there apart from the fact that it didn't have a flywheel. But that's not a problem. You can pick up Stuart Turner flywheels fairly easily, which I did, obviously, because that isn't a proper 10V flywheel on it. But yes, a few issues. Well, it would probably be easier to list the things that weren't wrong with it than the things that were. So why has it taken me 5 years to show this engine to you? Well, the vast majority of model steam engines that I work on could best be put into the toy steam engine category. They utilise very basic oscillating cylinders or piston valve engines, and they're generally made mainly of brass and copper, and they're fairly simple in their operation. And I like to understand the engines I'm working on, and before I do any work on them. So 5 years ago, my knowledge of Stuart Turner engines was basically non-existent. Yes, I did have my lovely 10H already, but that one is just a beautiful engine. I didn't have to do anything to that other than oil it to get it to work, and it's fine, and it's just wonderful. Worlds apart from this thing. When I first got it, I had a look at it, and I did manage to spot a few things. A couple of things actually that were wrong with it, but that was just the tip of the iceberg, because I didn't really know what I was looking at back then. I basically just, I thought, well, I don't know enough about this. I'll put it on the shelf and I'll try and gain some knowledge about these engines, and then I'll come back to it. Which is basically what I did. And it's at this point I want to say a massive shout out and thank you to a certain gentleman by the name of Mr. Keith Appleton. Now, if you're into model steam engines and you use YouTube, you'll almost certainly be aware of Keith, and you will be aware of his wonderful steam engine YouTube channel. Now, Keith's knowledge and experience is in much larger model steam engines, and he has been building them, restoring them, repairing them for many, many years, and he's a particular expert on Stuart Turners. So I basically set about devouring as many of his videos as I could, particularly those pertaining to the 10V, but just also the others on other Stuart Turner engines. And thanks to his videos, I was able to much better understand how these engines work. But not only that, he also shows you what to look for, and the things that can be wrong with these engines when, like my 10V, they're not made properly. So I couldn't have done this without the knowledge I gained from watching Keith's video. So Keith, if you're watching this, thank you very much. And also, if you're watching this, I do apologise for the red flywheel. I know you don't like red flywheels on Stuart Turners, but the flywheel on my 10H was already red, and I wanted the 10V one to match up with it. So that's why it's red. Okay, watched a lot of Keith's videos, and then I would, every now and again, pull the engine off the shelf, re-examine it, and find something else wrong with it, and started to strip it down. Now, this took me quite a long time, purely because I had loads of other projects that I was working on in the meantime, and I was literally it would sit on the shelf for months, and I'd pull it off and look at it and strip it down, try and work out what was going on with it, and so forth and so on. So yeah, that's why it's taken me so long to get it to the point where it actually runs. This is one of the problems I did actually manage to work out when I first got it. There is a lot of play in the crankshaft bearing blocks, and there still is. I haven't attempted to fix that yet, because basically there's only two ways to do this. You really need to machine up new bearing blocks, and really it could be, given the amount of play in that, it could probably do with a new crankshaft. So and that's, you know, quite major machining work to do that. So yes, but that in itself will not stop the engine from running. It's not ideal, obviously, but it won't stop the engine from running. So that is one of the problems. The other problem was more, I spotted, was just visual, really. So let's have a look at the top. On a close inspection of the top, this is the steam chest here, and obviously you've got the two cylinder end caps, the bottom one and the top one. So what was wrong there? Well, some of the studs were completely missing. Other studs were the wrong length. They should be gaskets on the steam chest and on the cylinder end caps. They were either missing or damaged, so I had to make new gaskets for it, and I managed to source some correct studs. I'm fairly certain they're correct. I'm not sure about the ones in the bottom that hold the bottom of the cylinder on. I think they're possibly too long, those studs, but they are at least all the same length now, which they weren't when I got it. And also, I don't know whether you can see this. I'll zoom in on it and see if you can spot it, because it's only a subtle difference, but because they're not an awful lot different in size. But that one, and that one are the right size. That one isn't. That's a 6BA stud. That's much bigger than these. So obviously at some point in time, the thread for this stud in the cylinder has stripped, and it's been tapped out a larger size. And that will bring us on to another problem later on. So yeah, so I basically got all that sorted out. While we're up there on the steam chest, we'll look at another problem. This time, this one's more cosmetic than it is will interfere with the running of the engine. That's the steam inlet port, that one there, and this is the steam exhaust port. And you're thinking, well, yeah, okay, so, well, on Stuart Turner engines, they are generally on opposite sides of the steam chest. So you would normally have the steam inlet port here, and this exhaust port would be on this side of the steam chest over here. When a Stuart Turner engine is made correctly, and the studs for the steam chest are drilled in the correct place on the cylinder, you can simply take the steam chest off, rotate it through 180 degrees, and bolt it back down again. Okay, but the holes for the studs on this one are not drilled in the right place. And not only that, of course, you've got that extra large stud which needs a larger clearance hole drilled through the steam chest, and that basically means you can't turn it around. So I'm kind of stuck with it like this. Now, as it happens, it worked out quite well, because obviously I want to pipe the exhaust into my chimney here, and it would have to come out this side, and it would probably overhang the end of the baseboard if I did that. But yeah, so that's another problem. So let's have a close look at the steam chest to explain what I'm talking about. You see this edge, that this is a lip that is overhanging the cylinder block by about 1 millimeter. That should not be there. The entire steam chest has been shifted this way by about 1 millimeter. So on the other side, it's a smooth, it lines up with the cylinder casting. On this side, it's overhanging. So it's not central to the cylinder casting, which is what it should be, basically. It should really be central. So that's another reason why I can't flip the steam chest round, and it just wouldn't work. So that's how it was when I got it, and I've left it like that. The steam chest works. I mean, the whole thing works, but it's not right. Basically, it's not right. So what next? This is the connecting rod which joins the crankshaft to the piston rod. That's the piston rod just in there, and this is the piston rod end. Now, what happens is the conrod has a U section in the top here, and the end of the piston rod is just a flat block with a small hole in it, and there is a pin, and that's the end of the pin. You can just see it there, right? That goes through those effectively 3 bits of brass. Now, what that pin is supposed to do, it's supposed to slide through from one side of the connecting rod, go through the piston rod block, and then it's threaded into this side of the conrod. You basically put the two together, put the pin in and screw it up, and that holds all that together. Except on this engine, I wasn't aware of this until I happened to turn the engine on its side and the pin dropped out. On this engine, the pin that holds those two together slides all the way through. There is no thread on either side of the conrod, and so the pin just pops right through. So yeah, not very helpful. There are basically 2 ways to fix it. The proper way is to actually machine up a new conrod, drill it and tap the hole and the clearance hole to the right sizes. Then you can use the standard pin and put it all together. What I could do is I could drill out the conrod and re-tap it slightly larger, but then I'd have to make a custom pin for it, which would make it obviously not a standard 10V. So I've done neither. I've basically bodged it to get it to run, and basically what I've done is the pin was a good fit, good sliding fit, so I've Loctited it this side and on the other side of the conrod, so it's Loctited into the conrod, but it's obviously still free to for the piston rod to rotate, and it rotates in the piston rod, and that's fine. It works fine. I don't think it's going to last very long because obviously this gets hot. Whether it gets hot enough to free off the Loctite, I don't know, but it works. Yet another problem. The next thing that was wrong with it, the timing was completely and utterly wrong. There are two parts to the timing. The first part is the slide valve, which is underneath this cover inside the valve chest. Well, I'm not going to take all that apart because I finally got that sealed nicely. So I will demonstrate on some Stuart Turner castings that I was very kindly given a few years ago. It's not a complete engine. It was a 10V casting. It's not complete, but some of the parts are there, and there's enough parts there for me to demonstrate to you exactly how the slide valve works and how it should be timed. What we have here are the rough castings for the Stuart Turner 10V. This is the cylinder block here, that's the steam chest, and that's the valve cover. Now obviously none of the holes have been drilled for studs or anything, but this is going to demonstrate quite nicely, what you see when you take it all off. So we'll have a top-down view, and I'll take the cover off and you can have a look at the slide valve. So I'll take the steam chest cover off, and there you go. There's your slide valve. I mean, there's a rod normally that goes through there, and there's a threaded bit in the middle, so that the rod will move the slide valve up and down as the eccentric rotates. So let's take the chest off, and we'll take the slide valve off. Now, these are your 3 ports: top steam inlet port, exhaust port, bottom steam inlet port. Okay. On the underside of the slide valve, there is a little milled out square, and that sits over those ports. Basically, the first part of timing the Stuart Turner engine is to set the slide valve up for 1 revolution of the crankshaft. It uncovers and covers both top and bottom steam inlet ports by equal amounts. So I'll close in on that and show you what I mean. Now it's in the middle at the moment. All ports are covered. So basically what you should get is, rotate the flywheel, the slide valve will move up or down depending on which way you move it, and uncover one of the steam ports. And what it's also doing at the same time is it's the little milled out passage on the back of the slide valve is connecting the other steam inlet port to the exhaust port. So that will allow any waste steam that's that end of the cylinder will then come out the inlet port and then through the little milled out slots in the bottom of the slide valve and then out the exhaust port. When you move it the other way, when you continue to rotate, that will close that steam port and open up the top one. Right, there we go. You just see it there. Now, what you want is you want those ports to be opened by exactly the same amount. So you want this thing central between the ports so that one rotation moves it exactly the same. It will obviously move at exactly the same amount in either direction, but you want this to open the bottom port and then close the bottom port and open the top port. But it wants to do it so that it is in exactly the same amount for both ports. So when I took the cover off, the steam chest cover off, this thing was right down at the bottom of the case, right? So the basically you're almost up against the edge of the steam chest, almost up against the bottom edge of the steam chest, right? And so what was happening was that once I got it so that it would actually rotate, the top steam port was uncovered all of the time, and the bottom steam port was hardly uncovered at all. So of course there's no way it's going to run like that. So that's the first thing, and basically the rod that slides through the middle of this, that moves this up and down, it's got a threaded bit, so you can adjust it, so you can literally move the slide valve up and down the rod, and that's how you adjust the timing. Now that's fairly easy to do. That's actually not too difficult at all. So that was that part of it. This is the second part of the timing. This is the eccentric. As you can see, that brass disc is the eccentric there, and as you can see it is off center, which is why it's an eccentric. Now there's a little grub screw there, and that locks the eccentric to the crankshaft. What you do is you undo that, loosen that off so that the eccentric is free to, you can rotate it on the crankshaft. Then you bring the piston up to top dead center. Then with the valve cover open, so you can see the slide valve, you rotate this, the eccentric, in the direction that the engine turns until the top inlet port is just coming open. Then you lock that into position on the crankshaft, and that's your engine timed. This, of course, was also completely in the wrong place. So there was no chance that this engine was ever going to run. The other thing was, it was also completely dry. There was no oil on any of it. It was totally devoid of any oil, so that all had to be sorted out. There's still some more to tell you, but I think that's enough waffle on my part for now. Let's get the whole plant prepped and we'll get the 10V running. Well, we're coming up to pressure. We're coming up to 40 psi, which would be more than enough to run this. I haven't shown you me prepping this because you've seen me do this, prep the steam plant before, basically oil up, top up the displacement lubricator. So right, let's see if we can get the 10V to run. I'll move the focus onto the 10V. Let's give it some steam. And there we go. Straight away you can see the wobble on the crankshaft by the flywheel wobbling. And runs quite nicely. Now that's maximum steam pressure, but this is what's wrong with it. No power whatsoever. I think that that's mainly due to, slow it down a bit, slop in the piston. The piston was quite a loose fit in the cylinder, so. But I do like to see that steam coming out of the chimney. It is lovely, isn't it? Right, let's close in on that for you. And that noise, obviously, again, is the slop in the crankshaft. Well, it runs, you know, which it did not do when I first received it. So let's change the angle a little bit. Yeah, I mean, yeah, it looks lovely, doesn't it? And it runs fine, and that's great, and all the rest of it. But compared to the 10H, which has oodles of torque, this thing's got like no power at all. So you can just stop it quite easily with your finger. Shouldn't be able to do that. But I am pleased that I've got it running. As I've said before, most of the knowledge that I've gained to get this to this state was through watching Keith Appleton's videos. So thank you again, Keith. Couldn't have done it without you, mate. I do like watching these engines run, even when it's a basket case like this. I still like watching it. See if I can turn it round a bit for you. I do love watching these. I know I keep saying that, but that's running at about 18 psi. Will run at low pressure, but of course, like I said, there's no power there, so it's not. You can't use the engine for anything other than to watch it run. But compared to what it was like when I got it 5 years ago, it's a hell of a lot better now. Well, I think that'll about wrap it up for the 10V for now. I hope to improve things with it in the future, but it does actually run. So I apologise for all the talk in this particular video, but it was necessary to explain what the hell was going on. But it does run. So I think we'll leave it there, and as always, I hope you enjoyed the video, and thank you very much for watching. Cheers!